So my name is Jean Villedieu. I'm one of the co-founders of Linkurious. And in today's talk, I will be talking about improving fraud detection and investigation with machine learning and graph analytics. So first, a quick word about the agenda that we will be going through together. To get started, I explain why graph and machine learning are complementary to fight against fraud. Then I will showcase a concrete approach to do that, which combines Linkurious Enterprise, Neo4j, but also Dataiku DSS. After that, there will be a demo, and then a few words of conclusion. So let's get started. So first, fraud is a big, massive problem. It's a $5 trillion problem, and it's growing quickly. It's a top priority for financial institutions, think bank, insurance companies, money transfer companies, but it's also a very top priority for public institutions. Tax agencies, for example, are very much interested in fighting back against fraud. So I want to start by outlining that both graph and machine learning, in and out of themselves, can bring a lot to the fight against fraud. So when we are looking specifically at graph, it can help detect complex patterns across different ops and relationships. It can also help by providing visual context, which is so important for fraud investigators. So that's for graph. Machine learning, on the other hand, can also be super helpful for anti-fraud. First, because it provides the possibility to go beyond static rules by using statistics. It's also a way to leverage human insights by turning the judgment of people into algorithms. So in and out of themselves, both machine learning and graph analytics are super powerful. What's interesting is that they can also reinforce one another. So for example, you can have the graph acting as an input for machine learning. So for example, you can use something like a PageRank score as a feature in your machine learning model. And the other way around is also true. Machine learning can act as a bit of an input for the graph. For example, you can use machine learning to do entity resolution and to fuse different data sources into one single graph. When combined, there's a lot of potential here. You can have a real impact in terms of accuracy, and I'm talking, lower false positives, lower false negatives, and it can also lead to faster investigations. So now let's take a bit of a step back and try to put ourselves in the shoes of fraudsters. What's important to understand is that these folks really have a lot of tactics, of schemes that they can use to defraud financial institutions and to avoid detection. For example, some fraud groups, some fraudsters are working as group to exploit a given scheme. So you have a criminal mastermind or a core group of criminals that franchise some sort of tactic or model to accomplices. And together they coordinate to exploit as much as possible that successful scheme. And typically they are interconnected, they are tied to one another. Sometimes you also have fraudsters colluding with insiders. So if, for example, you want to obtain a loan with no intention of paying it back, it can be helpful to secure the help of someone from the inside. And also here, there will be connections that will exist between the fraudsters and the man on the inside. Sometimes you also have fraudsters connected to one another to give the appearance of legitimacy to their actions. So maybe, I'm a fraudster and I have a bank account. I'm going to be sending money to some of my accomplices to sort of give the appearance of doing something legitimate. And oftentimes, you also have people using synthetic identities, so mixing pieces of information such as a phone number, an address, a social security number, to create fake identities that can be used to commit fraud with anonymity. And here, once again, you will have connections between the different parties across these shared pieces of information. What's interesting here is that the common thread in these different tactics is that it's imperative for anti-fraud teams to have a full understanding of the context surrounding their clients to be able to uncover those schemes, or at least stop them fast enough so that they can limit the cost. And here on the right, you can see a bit of an example of that. So you have a seemingly good client, and when looking at that one client in isolation, maybe it will appear legitimate. But if you look at the broader context, you see that indirectly that client is actually connected to another fraudster. And by taking into account that that context, these relationships, then you can understand that the seemingly good client is actually a potential fraud risk. So it's easy enough to do that for a given client, but the big challenge comes when we are trying to scale that to millions of clients and billions of transactions. And here, today's legacy rule-based systems, which are mostly based on relational databases and key-value stores, are really hitting a wall. And that means three big problems. The first one is that they focus on simple thresholds. So think how many transactions in the last 30 days, that kind of things, which work to a certain extent, but is easy to bypass when you are a smart criminal. Another issue is that suspicious connections are actually very rarely uncovered. The data is scattered across different tools, different databases, different types. And oftentimes it comes down to having the investigator having to piece it all together, maybe by running a phone number in different systems to see if there are matches and connections that you would otherwise miss. And finally, these systems, they tend to generate a lot of false positives. So you have anti-fraud teams chasing their tails instead of working to smart criminals. And graph and machine learning can really change that, can turn the tables against criminals for three reasons. The first one is that it's a possibility to have much faster investigations. With entity resolution, graph visualization, it becomes possible to provide to any fraud analyst a full context of any suspicious situation, and that can drive faster and better decisions. Secondly, with graph, with machine learning, you can set up analytics that are going to be smarter than simple thresholds, and that will catch not just the criminals that are not super sophisticated, but also the professional criminals, which are super, which can drive a lot of damages. And finally, machine learning can help reduce false positives by turning human insights and in an asset for models. Now I want to showcase a concrete approach to combining this machine learning and these graph analytics techniques for anti-fraud, and it's going to rely on three different technologies. The first one is Linkurious Enterprise. Linkurious Enterprise is an investigation platform that relies on graph analytics to facilitate the detection of fraudsters. It's also used in cybersecurity, money laundering, and national security. With Linkurious Enterprise, analysts can easily detect and investigate suspicious activities. All of that in a secure and collaborative environment. Linkurious Enterprise is directly compatible with Neo4j, so you can get started in minutes if you already have a Neo4j instance. And it can be deployed on the cloud or on-premise. We will also be using Dataiku DSS, which is a data science platform, and it helps business users and data scientists leverage AI at every stage of a financial crime project. And finally, we will also use Neo4j, the most popular graph database out there. So here is what it looks like from an architecture perspective. So you have data stored in legacy systems. It flows to Dataiku, where it is both enriched, fused, and also enriched via machine learning scoring, I guess. Then this data can be used to create a graph stored in Neo4j, where Neo4j can help with the storage, but also help with running graph analytics. And finally, all of that is made available to end users, fraud analysts typically, via the Linkurious Enterprise UI, where anti-fraud teams can work on cases, but also conduct investigations. So that's for the architecture of this solution. Now I would like to showcase that via a very concrete example. So we are going to go through a demo together, and the goal here is really to take you through all the steps of applying machine learning and graph analytics to curb fraud. So we will be using a fake data set with clients, transactions, information about clients, and we will be hunting for fraud together. So I'm going to switch my screen. Okay. So this is the Dataiku DSS interface. So you can see some information about the demo, but what I'm interested in is in the flow section. So in that flow section, we are going to go together for steps of our fraud project. So we will discuss data preparation. Then we will build a machine learning prediction model. And finally, we will use all of that to build a graph. Okay, so let's get started. So here is the original data that we use for the demo, studying in a relational database, a Postgres database. So for example, here we have a person table with Dataiku. We can clean that table. So let's look at what it looks like. So we can remove some columns for example, but we can go beyond that. For example, here we can compute the geo-coordinates of an IP address, and we can compare these coordinates with the coordinates of the address to see if there's distance between the IP which is used by the client to connect to his or her account and his or her reported address. So we are really adding information to the raw data. So that's for the persons, I guess. Let's see another example of that. So here we have transactions. These transactions are going also to be enriched. So we are looking at aggregations. So we see, for example, that we take the amount property and we compute a minimum, a maximum. We compute the standard deviation. So a few extra information that will help us down the line. Okay, so all of this data is flowing through the system. Here we see that we also enrich again the transactions. So among other things, we are, for example, extracting from the dates the transactions that are happening during holidays. Okay, so that's based on the country code, and we are also identifying within the data set the transactions across countries. So once again, it's all about enriching the data. Okay, so let's go back to the flow now. Ultimately, this data ends up in this big table. So that's for the data preparation part. Now let's look into how to use that to make predictions via machine learning. Okay. So here we have another zone dedicated to machine learning. It takes as an input that transaction file or table that we have built together, and we are going to build a model, then apply that model to the file, and ultimately we put a bunch of predictions, So now let's look into that more specifically. So in this step, we set up some parameters related to the experiment that we'll run. Specifically, we are going to be using 80% of the data for training and 20% to test our model. So we can set that up here. Here we actually build the model. So let's look into that. So I'm going to go to view original analysis, then hit design, so that we can design the machine learning model together. So we see first that we are going to make a very specific type of prediction, which is a two-class classification. We want to know whether a transaction is fraudulent or not. So it's as simple as that. In our original data set, we have about 99% of non-fraudulent transaction, and we have labeled 1% of fraudulent transactions. Okay. We can make some extra tweaks. So, for example, we can, choose what will be used as features in our machine learning model. So, for example, the ID, maybe not so relevant, whereas there are other things that are of more interest. For the numerical properties, we can also rescale them to make it easier to leverage them in our models. And among the features that we can use, we can definitely leverage all of the the data enrichment that we have done in the earlier stages of the project. Okay, so that's for the features handling. Now let's look a little bit at the algorithms. So you have access, in a very easy fashion to a few algorithms. For this demo, we are going to be focusing on two algorithms, the random forest algorithm and the logistic regression algorithm. They tend to perform well with a great number of features. So that's one thing. And the second thing is that they tend to give results that are easy to understand, which is quite important in the financial crime context, where ultimately we are talking about important decisions impacting clients, and we want the people making those decisions to understand what is going on and why the algorithm is suggesting some things. So here we are really designing the model. Okay. Now we are going to be looking at the results of our model, and we can see that the best performing algorithm seems to be the random forest algorithm. So for us, it's the one that gives the best predictions. And here you can see some of the important variables associated with that algorithm. So for example, we see that the distance between the IP address and the address is actually something that is fairly for the model. So the greater the distance, the higher the risk that we are looking at something fishy. Okay, so we have built that model. Let's go back to the flow now. Next, we are basically using the model on the original data, and we are making predictions about which transaction is likely to be suspicious or not, and that result ultimately it's going to end up as a new table. Okay, so we have prepared the data, and then we have built a model that we have applied to make some predictions. So that's what we have already done. At this point, we'll see that we are going to be using Dataiku DSS to actually turn all of that into a Neo4j stored graph. So for this, we will be using a Neo4j plugin. So if you're using Dataiku DSS, it's super easy. It's in the plugin store. Setting it up is fairly trivial. You need to provide an address, the username, password, this type of information. Okay. Okay, going back. So we have seen the plugin now, and we are going to actually leverage that plugin. So, for example, here we see that we are using a person table. Okay. So that's a person table, and we are sorry about that. So it's right there, and then we use the plugin here. So to create a person node, so we see the label that we set. We see the different properties that we are associating with that type of node. So fairly easy to do. Okay, going back now, and then all of that is used to create the graph. So here we have seen how to create a node, I guess. Now we will see that it's also possible to create relationships. So here is an example where we are handling transactions. So we are connecting bank accounts to transactions via asset relationship. So we are specifying a primary key for the source and target, and then we are defining all the properties that we want to capture. Okay, so we have seen how to move from raw data to a Neo4j stored graph now with Dataiku DSS. Now let's talk a little bit about how to actually exploit that. So I'm going to move to Linkurious Enterprise now. Okay, so this is the Linkurious Enterprise UI. So that's really where fraud analysts can come and conduct their investigations. So we will see how to use the power of machine learning to generate some alerts. So I'm going to go ahead and click on alerts here. So we have created an alert about suspicious transactions. So I'm going to show you what it looks like from the perspective of a developer or data scientist. So let's hit edit. So you can see it's actually a graph query written in Cypher, and we are looking for a specific pattern. So we want to find entities that are connected to bank accounts that are connected via a transfer relationship to another bank account and another entity. And we want, that asset transfer relationship to have a score above a certain threshold, which is 0.9. So that score property is actually the output of the machine learning algorithm. Each transaction has been scored based on that algorithm, and here we are just cherry picking the most suspicious transactions. So Linkurious Enterprise is going to be running that query and creating a new case every time that the pattern emerges. So it really, it's the combination of machine learning powered by Dataiku DSS, and then graph, which is leveraged via the Linkurious Enterprise UI. Okay. So now let's look at the results. So we see that we have 6 suspicious situations. So I'm going to go ahead and pick one. So here is an example. So Linkurious Enterprise is loading the case. So we see some information. We see a client, a bank account, another bank account, and then a client. I can, double click, expand. If I want to, I can make save whatever done. I can also add a small comment here to what I've uncovered. I can arrange my case in different buckets. For example, I can say, okay, it's dismissed because it's not relevant, or I can say, indeed, it's confirmed because I think it's indeed a suspicious situation. If I'm not sure about what I'm looking at, I can actually bring all of the data into the full Linkurious Enterprise UI for deeper investigation. So for example, I'm going to select those 2 clients, and I'm going to use what we call a query template, which is a parameterized graph query. Sorry. To find everything that these 2 clients are connected to. Okay. And then I'm going to do that again. Okay. Okay. So here we have a full understanding of what's going on. In the center, we have that one suspicious transaction. It's highlighted in red because it has a higher risk score than the other transactions. And what's interesting to me, and that what really pops up right now, is that it's not just that one transaction that's a problem. We see that around that transaction, there are a lot of weird things happening. So we have 1, 2, 3, 4, and I guess 5 clients, and they are all interconnected across one address here. Here we have a phone number. Here we have another address. Here we have an IP address. So it seems that these people are sharing personal pieces of information, which is something a bit weird. I can plot the data on a map if I want to, okay, to see where all of this is happening. So it's somewhere in the Chicago region, apparently. If I want, to understand deeper what's going on, I can also slice and dice the data. So maybe I want, to remove the addresses, the emails, the IP addresses, the loans, the phone numbers, to just, focus on the financial aspect of the situation. These transactions, I can, filter them further, maybe focusing on the specific, on the ones with the biggest amount. Okay, so I can do that. If I think that my visualization is a little bit overloaded with information, I can also group some transactions. Here we see that between this account and this account, and this account and this account, there are multiple transactions. We can group things to unclutter the visualization. Okay. So Linkurious Enterprise really gives you a few tools to filter out what's not relevant and focus on the important part of what's inside your visualization. And all of that is easy to access for non-specialists, non-graph gurus. Okay, so we have been able to pivot from Dataiku DSS to Neo4j and now to Linkurious Enterprise, where via machine learning, we identified something suspicious, which we confirmed via visual investigation of the situation, and now we can save that. We can share that across colleagues. Okay, let's go back now to our presentation. So what I've tried to highlight is really an approach that is based on best of breed. So it leverages tools that are best in class in their domains, and it's a way to really enhance your anti-fraud arsenal. Both graph and machine learning, separately and together, can provide meaningful improvements to existing anti-fraud approaches. What's also interesting about the approach that I just showcased is that it's something that gives a lot of control to financial institutions that want to go in that route. With a modular architecture and with APIs, you can either enhance an existing system by adding new alerts or new visualization capabilities to your case management or investigation tools. So it's, or you can, go the other route and really use this approach as the backbone of your future anti-fraud infrastructure. Something else which I want to highlight is that it's really a platform built for everyone. So you can have fraud analysts, data engineers, data scientists, DevOps, managers, all working together at different stages of a fraud project, such as data integration, risk scoring, investigation. And that's, in our experience, can drive faster results. So here is a slide that explains how it all works, and it starts with the legacy system, where typically you can have access to internal data such as KYC information, transactions, but also existing scoring engines. You can also combine that with external data. Think data about politically exposed persons, data from company registries, data from watch lists, all of that. Then we have seen how Dataiku can help with the data ingestion. So Dataiku can be used to manage the pipeline, but also to do entity resolution, all of that to create a full picture of your data. Dataiku comes with 40 plus connectors with different data sources. And then you can use Dataiku DSS to leverage machine learning and to use that to create alerts. And here you have a lot of features of capabilities that you can leverage, such as the auto ML functionality that really makes the use of machine learning accessible to everyone. Then the data can be moved to Neo4j, where you can use Neo4j to store and analyze the relationships in your data. And here at Linkurious, we can also help with different assets such as data model, pre-built alerts that can help fast-track projects. And finally, all of that can be accessed via the Linkurious Enterprise UI, where you can review alerts and investigate. And we can provide different accelerators here in terms of pre-built workflows, and we have seen one of those in the form of a query template, but also with visualization settings that will make the important aspects of your data really stand out. All of this architecture is something that can work on-premise or in the cloud. It can work in real time or in batch mode, and it can scale to even the largest data sets. So today at Linkurious, we are working with thousands of analysts throughout the world. Some of them are using our software for anti-fraud. Others are working on anti-money laundering, cybersecurity, or other use cases. If you want to learn more or even try Linkurious Enterprise, you can either visit www.linkurious.us or drop us an email at contact@linkurious.us. Thank you very much.